All right, so for today's deep dive, we're looking at a piece of hardware with a name that's just wild.
Yeah.
It's the NTI ST-1FODVI-R-SC-MDP. It sounds less like a product and more like my Wi-Fi password.
It's absolute alphabet soup, I know. But if you strip all that away, what you're really holding is basically a teleportation device for video.
And that's what grabbed me. Because usually when I'm running a DVI cable, I start getting nervous after, 15 feet?
Oh, yeah, you start to see it.
You get the sparkles, the signal drops, it's a mess. But this thing claims it can throw a signal 3,280 feet.
A full kilometer. It's incredible.
A kilometer.
And that, I think, is the mission for us today. How do you take this really fragile, high bandwidth signal and just push it across a massive space like an airport or a stadium without it just turning into noise?
And just to be clear for everyone, this specific unit, the R, in that super long name, is just the receiver part.
Right. It's the catcher's mitt at the end of the line.
Yep.
It's part of a whole system they call VOPEX. So you've got a transmitter at the source, maybe a splitter in the middle somewhere.
And then this little box at the display.
Exactly. But the how is really the cool part. It's actually in the name, in the acronym, FODVI, fiber optic DVI.
Which explains the insane distance. I mean, if you tried to run a copper cable a kilometer, you basically just build a giant antenna for interference.
Precisely. Copy just loves to pick up RF interference, especially in, say, an industrial setting with big motors and all that electrical noise.
But fiber uses light.
Yep. It's totally immune. You're swapping electrons for photons.
So the specs mention it uses a single-strand multimode SC fiber. But what's actually making the light? What's, generating that signal?
Okay, so this part is for the real hardware nerds listening. The optical source is an 850 nanometer VCSEL.
A VCSE, vertical cavity surface emitting laser.
That's the one. And it's a class 1 safety laser, which is important. VCSELs are just incredibly efficient, and they can modulate or blink super fast.
Which is exactly what you need for a video signal.
But, and there is always a but when you're dealing with physics, even a laser has its limits. And the spec sheet shows this really interesting trade-off.
I saw that. The device has a bandwidth limit, right? A hard cap of 1.65 gigabits per second.
That's your pipe. You can't fit any more data through than that.
So it creates this kind of sliding scale.
It does, a scale between distance and resolution. So if you keep your cable run under, say, 984 feet, you're golden. You get full WUXGA resolution. That's 1920 by 1200.
Which is actually better than standard 1080p. It's sharp.
Very sharp. But if you need to push it, if you need to go that full kilometer,
you got to give something up.
You do. You have to throttle down the sheer number of pixels to keep the signal clean. At 3,280 feet, the max resolution drops to 124 by 760 XGA.
Which is fine for like a big digital sign or a flight information board.
Absolutely. But you're not going to be editing 4K video on it from a kilometer away. You have to pick your battle distance or pixel density.
Now, you'd think something this powerful would be, I don't know, the size of a brick. But the dimensions on this thing, it's tiny. About 1.5 inches by 2.5 inches.
It's shockingly small. And that's really crucial for the installers. You can tuck this right behind a flat panel display and no one will ever see it.
And they built it so you can run the fiber through conduit first before you attach the hardware.
Oh, that's a lifesaver. Anyone who's tried to pull a giant pre-made DVI connector through a narrow pipe, they get it.
It's a nightmare. There's another feature listed here that seems just as important for installers: EDI learning.
Ah, the handshake.
Right. The extended display identification data. So many times with extenders, the computer has no idea what it's plugged into, and it just defaults to a garbage resolution.
And this receiver solves that. It basically learns what the monitor is, and then it pretends to be that monitor. It sends that info all the way back to the source computer.
So the PC just thinks it's plugged directly into the screen, no headaches.
No configuration nightmares, it just works.
Which, I guess, brings us to the price. It's listed at $610.
Which sounds like a lot for a cable, but you're not paying for a cable. You're paying for reliability. This is industrial-grade gear.
Yeah.
I mean, if that departure screen at the airport goes black, that's a way bigger problem than your game crashing at home.
It's like you're buying insurance against the laws of physics.
That's a great way to put it.
So to wrap up, we have this tiny box that uses a vertical cavity laser to shoot a video signal down a thread of glass, ignoring all electrical noise, to light up a screen nearly a kilometer away.
It really just pulls back the curtain on the invisible infrastructure that's all around us.
I think that's the perfect final thought.
Yeah.
The next time you're in a stadium or an airport and you look up at one of those giant digital signs,
Mhm.
just, take a second to think about the invisible pulse of laser light that's probably racing through a hidden glass fiber to make that image appear right in front of you.
And if it looks a little bit blurry, they probably ran the cable just a bit too far.